Good afternoon, and welcome to what I think will be a really terrific panel today. Today, we're going to look at how we can enable U.S. consumer use of 5G. There's a lot of excitement about the potential benefits of 5G and how it could revolutionize government and civilian activities. But there are some significant hurdles as well. I think a lot of us expected to have 5G rolled out a little bit faster than we're seeing it being rolled out. So today, we're hoping to shed some light on the pace of 5G rollout and how we can partner throughout the civilian and industry sectors. I'm Kelly Fletcher, here from the DoD CIO, and I can tell you that here we're wrestling with these issues every day. Today, I'm really excited to be joined by some experts, so we're going to have a great conversation. First, I'd like to introduce Catherine Coulter-Mitchell. She is the senior official performing the duties of the Undersecretary for Science and Technology at the Department of Homeland Security. Next, Dr. Eric Berger, a research professor of computer science at Georgetown University, and also the technical program director from NextG Alliance. Finally, Bill Bloomingdale is the 5G strategy lead at Leidos, and he's going to bring in a very important perspective from industry. So with that, let's get right into the first question. I'm really excited about 5G technology, and I think we're going to have a lot of opportunities across a whole range of applications. We've seen carriers and companies make significant investments to roll out networks, but some view this rollout as a little bit slow. It might be helpful if we talk at a high level about the benefits that 5G can bring us and what are some of the major obstacles as we look to get this deployed. So Bill, let's start with you.
Yeah, thank you, Kelly. 5G is a very interesting technology. It's very complicated. If you think about 4G was about connectivity. So it is getting the internet to the mass everywhere. 5G is about enabling a user immersive experience. If you hear all the use cases that 5G talks about, whether it's fantastic stuff like remote surgery or more commonly autonomous vehicle management, or augmented reality, co-presence solutions. They all have a couple of things in common. They have edge computing and low latency access. And so when you compare that to what 4G was, 4G, the operators generally brought an end-to-end solution where there was few points of data access in their network. 5G, they need like a leaky bucket. So the network topology has to change significantly. So you got the need for transport revolution inside of their network to enable the routing to happen to the edge to create low latency access, as well as the deployment of additional spectrum for supporting the higher throughput capacity needed to also affect the latency access. And so that takes a lot of planning, timing, transformation, especially of the size of networks of our tier 1 mobile operators. So towers are just one aspect. But you think about the edge compute, 5G itself doesn't provide edge compute. It just provides a transport. It's just a connectivity. So there's nothing magic to it. It's just connection. But it's like an enterprise routing capability. So if you're going to route to in the old days, if you were in a rural town, your data went all the way to a central location. Now it could be dumped right there at the city in your little town to the Amazon AWS server, or Azure server, Google Cloud Platform server, name your cloud access to enable that access. So all of that has to work in concert. You got the C-band spectrum that's come out. You have this transformation inside inside these networks. So it just takes time to enable the use cases. I think it's going to take another 2 or 3 years, and then it will be fantastic. And then the next time we talk about it, it'll be like, wow, whose app is really doing what? So, but that's why it's taken a little bit longer than everybody's expected, because it's such a big transformation of the networks of how data is routed. So, over to you.
Thanks. I love your point about there's nothing magic to it. Like that's, it feels a little magical, but it's nice to just sort of think about. I love how you laid out, like, there's just a bunch of hard work that has to happen.
Yeah.
From like a more academic perspective, Eric, do you have anything on that as well?
Well, yes, so thanks. And Kelly, good afternoon as well. I would say that we're rolling out almost on schedule. If you look at the rollout of 4G LTE, there were a couple of trials and people, carriers getting their toes in the water around 2008, 2009. And as Bill said, by 2012, 2013, no one was talking about, oh, I need this special thing. It was just what you got. I would offer that the spectrum is much more complicated now. The clearing of the C-band is just getting underway. There's a new auction of the 3.5 gigahertz band that's about to start. And so clearly, there's physics involved here. You need to build towers, put up radios, configure. The other thing is, one of the things that 5G brings is the industrial Internet of Things. And that's where we're going to need to see not only, as Bill said, the network architecture change, but possibly the subscription models change. It's not likely that a device that costs $5 and is monitoring power usage or machine arm actuators is not going to have a $50 a month subscription like we see with consumer devices. So these are all things that need to be worked out, and I would offer we're kind of on track for working those issues out.
All right, thank you. And I do think you hit on something that's really, really notable, is that there is all kinds of use for this. So, across all sectors, Internet of Things, we're talking about civilian use, commercial use, law enforcement. Really, we're going to be using 5G sort of across the full spectrum of things that humans do. And as we think about that, something that I keep hearing about is standardization and trying to balance competing demands. So when we think about spectrum standards, is that something that could help? Do we already have enough of those? How is that going to work, do you think?
Well, yeah, I mean, really what makes communications work is interoperability. And it's from basic economic theory. We know that the value of networks grow faster than the numbers of users on that network. And that's what's known as the network effect. In fact, it's somewhere around n squared. If you have 10 users on one and 10 users on another, when you put them together, it's not worth 20, it's worth 100. So, we have kind of two choices here. One is to have one large network, and this, in fact, was the model in the mid-20th century in the United States. We had AT&T, and then a couple of others, but for the most part, it was AT&T. The other alternative is to establish standards to ensure a user on one network can easily communicate with a user on another network. This makes the network have scale with different operators, which means we get the network effect from everyone being able to talk to each other and all the goodness that competition brings. On the spectrum front, in the 1990s and 2000s, if you traveled outside the US or even in the US between different carriers, your phone wouldn't work. You need to rent a phone or get multiple phones. There were three major wireless standards, and most phones would not talk if you were on the wrong network or in the wrong country. And so in the standardization world, 3G began this, and 4G LTE really completed the migration to fully interoperable spectrum standards in the mobile world. Today, you don't need to think, am I with an AT&T phone and a Verizon network, or a T-Mobile phone and an AT&T network? It all just works. But the thing to remember is mobile communications is not the only use of spectrum. Radar, for example, has very different characteristics than communications. Satellite observations, Earth observations, are incredibly sensitive to what's going on in adjacent bands. And in times of great need, everyone agrees that national security and emergency communications are more important than watching a movie, playing a game, or gossiping with one's neighbor. Industry, government, and academia have recognized these needs and have been working together for decades in fora such as the ITOR, IEEE, and 3GPP. North American specific standards development organizations such as ANSI and ATIS provide inputs to these global organizations, as well as develop regional standards for when we do have unique requirements. And really, some might say that the US failed to participate in the development of 5G in the early 2010s. The predominantly European vendors did address some of the needs of US carriers in the development of 5G, but with the exception of Qualcomm and InterDigital, the major US companies were mostly absent. And given the audience today, perhaps the most important needs missing from the discussion were federal, state, local, and tribal governments. Also, given the high density of the European continent and cities in China, issues such as rural broadband were not addressed. And that really ties into what's going on with the NextG Alliance and ATIS. Basically, it's a bold new initiative to advance North American mobile technology leadership over the next decade. And we've got over 50 American traditional network operators, hyperscalers, legacy and cloud native equipment manufacturers. And there are over 10 universities and FFRDCs. And what we're working on is promoting academic, industrial, national laboratory research, strong technology commercialization by the private sector, and the appropriate federal, state, and local policies and support for R&D, manufacture, and deployment. So basically, rather than fighting the adversaries head on, we're moving the playing field to where we're the strongest. Entrepreneurship and out-of-the-box innovation, security and privacy, and networks built to respect the rule of law.
Those are great points. I love that you brought up, I had forgotten when mobile phones didn't work. And I, as like a consumer, I care deeply about that. And then at my job, I care so deeply about radars. So you hit on, I think, two things that really just sort of bring it home to me. And looking at this sort of, as we look at standards, I know the government's going to have a big role in that. So Catherine, anything to add from your perspective?
Absolutely. I think for government, S&T specifically has always been a huge proponent of open standards. We used to have, in addition to mobile phones that didn't used to talk, we experienced this problem with LTE radios for our first responders not being able to talk as well, and realizing the challenges that came along with that. So working with our partners across the interagency, figuring out what those open standards should be to ensure that cross communication and interoperability will absolutely be critical for all of our operators. And I think the challenge we're facing right now is actually figuring out in the department what we're going to use 5G for, and identifying those use cases that Bill and Eric had mentioned. So at S&T, we're working with our components to really identify what those use cases will be based on Internet of Things and other uses across the department, so that we can bring those forward and make sure that those are addressed in the bigger conversation as well.
Yeah, that's great. I think we're going to find out a lot, right? As we roll out 5G, we'll find more and more uses, I think. And that sort of brings up another point of where we have some government and private sector partnership, where we need to have this partnership. And that's in research and development. So I'm curious to know from your S&T perspective, what are you all investing in for R&D? Where are you partnering with industry? What are the cool R&D things happening?
Sure. Well, there's a lot of cool things going on in this area and a lot of others, but really collaboration and public-private partnerships are going to be the key to all of this. It really, truly needs to be a team effort across all three. And I know sometimes we try and define what those lines are, but I think we get in a real danger zone if we actually divide up and conquer, as opposed to really working hand in hand throughout the entire process to make sure that everything runs smoothly. But just to give you a couple examples of things we are working on that we see as something we can assist with. So we're working with DoD and DARPA and NSF, who are putting a huge number of resources, more than we could ever dream of having, of course, into this challenge, and making sure that together we pull those resources and are able to really go at this challenge together as a whole of government approach to executing the 5G issue. We're collaborating across nearly 50 federal agencies and what we call the Federal Mobility Working Group, the FMG, which enables us all to share ideas, knowledge products, and testing information as well. We're also working with our colleagues at CISA in DHS, which is our cybersecurity agency, to help components better understand what 5G has to offer them and where it might actually be helpful, and again, putting those use cases forward. And some of the R&D we're really working on, and what we call our technology centers, are the architecture and algorithms research that would help promote the fair and equal access, as well as some test bed availability. So I think those are the areas where we see we can help this much larger challenge. But again, I think all of it really needs to be hand in hand and not divided up, so that at the end of the day, we have a joint both use case as well as solution that's interoperable, as well as private and public useful across the spectrum.
Yeah, absolutely. And I know DoD, we have a lot of different pilot activities, and I know we're partnering with you all and with NSF and with across the government. And also, I think to some degree with industry. But I think, Bill, can you speak to sort of what are your key focus areas in R&D now?
I think the big ones for us is trying to figure out how to access the edge computing in a way that is secure and seamless. And when you think about how mobile phones work, if you're inside the building, generally you're on Wi-Fi. If you go outside the building, you're on mobile. So how do you maintain those connectivities? How does it transfer to multi-networks? And if you take some of the DoD use cases for their systems, they're multi-network as well. You got tactical radio, you got mobile. And so there's a lot of aspects of how do you transfer what they're doing to a 5G construct, as well as support legacy connectivity. So we've had a lot of focus on the whole cyber aspect of how do you enable the edge compute. We have a big push with a program that we call Edge to Cloud, which will enable the 5G edge. I mean, we talked about earlier where 5G itself doesn't provide all the edge compute. It gives you access to it. So case in point, like Verizon has a contract with Amazon for their wavelength program that's inside AT&T announced with Google cloud platform just recently. And so you have multi-cloud, you have these different enclaves you're going to have to put your apps into. So it's a pretty big effort to actually enable the apps to work across. So a lot of our R&D has actually been on that side of the front of trying to facilitate these use cases, give the structure to be able to do it, as well in a secure way that the government likes to operate, which can also feed into just general enterprise as well. So that's a big focus of ours right now.
Yeah, I like that you referenced security, because I think that's a domain where, like, I have a lot of, coming from a DoD CIO perspective, I have a lot of interest in that. And Eric, do you have anything from an academic? I know this is when I think R&D, I think of.
That's right. That's right. And although I do want to, and even we have an involvement in this, Georgetown, you're being very modest with the DoD activities here. The FMG that Catherine mentioned really did a great job looking at the needs of the federal enterprise. And there are a lot of unique needs of the federal enterprise. And the DoD 5G test beds, yes, a few of them are about what I would call guns and bullets, but most of them are directly applicable to, how should we say, private sector enterprise. Using augmented reality to find a carton of toilet paper in a warehouse is the same as finding a carton of toilet paper in a warehouse. It's not even finding a box of bullets. It's like literally the same stuff. Likewise, augmented reality and virtual reality for training, like on repairing a Humvee, is literally identical to fixing a Hummer, which would be the same for a Toyota. So these are truly dual use. And that's part of what the theory is getting companies and academic researchers involved with creating these applications that then can go off and become new companies, can really drive the new ecosystem. So yeah, I could talk and wax poetic about the work we're doing on like 5G network slicing for first responders and national security communications. But I'm clearly more excited about these things that have the true dual use, that are useful for everybody.
Yeah, I actually, thank you for bringing these up. I love the stuff we're doing in logistics. I love the stuff that we're doing in maintenance. Like, as you point out exactly, it's useful across a lot of industries to be able to find a creative toilet paper. And then even the Internet of Things stuff, right? That is useful as just like a human in a home. You know, I think a lot of it is going to be useful from a big industry perspective, but then I also think a lot of it will also trickle down to like individuals, which is really cool. So with that, I do want to talk about, you know, something you brought up earlier about like your phone working certain places and not other places. How does this work? And the one place where I see that still is if I travel abroad. And this is obviously there's less of that happening now, but I hope that it will return. So as we look at the use of 5G globally, what do we need to be doing, you know, as a government, as industry partners, to sort of get some global standards so that we can position US industries to be successful globally, so that, you know, our federal folks, as they travel for work, they're able to be successful? What should we be doing? Bill, can we start with you on that one?
Yeah, it really drives into engaging the standards bodies. I mean, if you know, if you're going to try to enable a global aspect, it's really about the standards. I know we're talking about 5G, but I'm going to use the Wi-Fi extended, the unlicensed band extended right now as a really good reason for engaging the Wi-Fi, the standards bodies. You know, the standards bodies of Wi-Fi, the Wi-Fi Alliance, all the technology partners there, as well as working with regulatory groups, have done a public-private partnership to come up with a way to engage a new spectrum band to do efficiency gains, right? You know, I think this band was finally approved here in January. You know, Samsung came out with a device that used it and has put pressure for the globe to adopt the same spectrum. So in the EU, they just approved a partial of the band. I think that like Brazil's approved it, Canada's approved it, and it's being heavily looked at consideration in a lot of partner countries like Australia. You know, I mean, even Russia's looking at it, and some of the other Asian countries. And so through standards bodies, you can affect that global change. So now when you have your Wi-Fi device and you go to Europe, if it's extended band, you can get on those additional spectrum bands to have higher capacity, better performance, and more ubiquitous, same use case kind of feel when you go country to country. So whether you're trying to drive a feature of how network slicing works in 5G or how an industrial use case works, the real drive has to be in the standards bodies, because technology now is global. I mean, you know, it used to be, you know, as Eric was describing, you know, Samsung made a phone for Verizon. They made a different phone for Vodafone. Now it's you buy an Apple, you know, 12. You know, iPhone 12, and it's the same, basically the same phone globally, right? And so that standardization happens because of standards. So we got to get into the standards bodies as a global, you know, as a U.S. community, whether it's the technology partners in the government, to try to make certain that we put in things that help us, you know, interact globally, as well as make certain our technology partners are you know, are heard and their technology can be added for to shape the standards. That's really where it comes down to.
Yeah, those were great points. And I think we were all sort of nodding as you talked about standards. Unfortunately, I think we are actually just about out of time. I hope for folks who watch this, we were able to shed some light on this complex problem. The things I'm going to take away, my favorite things were there's nothing magic to it. I think that's actually something good to remember. There's a lot of physics, and then standards are important. So, but I really appreciate my panelists, Catherine, Bill, Eric, exceptional. And I hope that you all enjoy the rest of the FedTalks as well. So with that, thank you all again. Thank you very much for your time, and thank you for watching.
Thank you. Thank you.
Thank you.
Kelly.
Yeah.